Welcome to Revolution Against Evolution. I'm your host, Doug Sharp.
I'm Rich Geer here with you, and we had a trip out last year, and it's just we had a very wonderful. Was it Jim Clarke was going to give us a little tour, Doug? Is that what's going to happen?
Yeah, we were at in the Phoenix area at Papago Park, and we did a number of different things on this trip.
A lot of things.
We visited South Mountain. You weren't there for that.
No, I got in the next day after that. Yeah, you guys were there.
We then went down to just a little bit past Tucson and visited the Empire Mountains, and that's another spot where the geology is very interesting. Then we went to the Canyon Lake. We took a boat trip out to Canyon Lake.
Yeah. We
went to the Boyce Thompson Arboretum, and we did a tour with David Oberpriller, and he gave us a tour of the plants of the Bible. And this was a day with Jim Clarke. He's the guy who arranged the boat trip. And so he took us to Papago Park. Now, Papago Park is right in the middle of downtown Phoenix. You know,
well, it's not really right downtown. It's a little bit off to the side, isn't it? I mean,
a little bit.
Yeah, but it's right next to it. But it's really cool. It's like when you go out there, you just want to go running around. It's just a lot of nice trails and the shapes of these mounds, Doug, are just all this red, all bunched up, all kinds of stuff, and Jim was telling us a lot of stuff about that.
Yeah, one of the things, there's a desert botanical gardens there that we visited, and that was really nice. And you can see these buttes from the desert botanical gardens.
The buttes were buttes.
Yes, but it's interesting. They talked about how one butte had a whole bunch of vegetation on it, and the other one was just didn't have anything on it at all. And it's just because the composition of the rock was different.
Right.
And so the one you could see all the saguaro cactus going up the side of it, but the other one it was just naked.
Yeah, naked. But I just like Doug. We were hiking, because you and I have been there before. Because your daughter lives out there, and we've hiked this place before. But it's really neat to have Jim really fill us in on a lot of the stuff, the mountains, or in the distance, what made them from a creationist viewpoint. He was really sharing a lot of stuff, and these things were like big conglomerates, what we were walking on, and it's like nothing's growing on the ones we were on. It's pretty much just barren, like scumbled up all kinds of stuff, Doug. And Jim really took us on a wonderful little tour and telling us all about all this stuff.
Yeah, and we're going to let him do that. But what I wanted to do before that is just talk a little bit about our experience on South Mountain and at the Empire Mountains.
Okay, yeah.
Because South Mountain and the Empire Mountains are upside down, and I knew that about the Empire Mountains. Yeah. But we really didn't realize that the South Mountain also had a issue with Precambrian rock on top, Tertiary rock on the bottom. That just inverts the entire geologic column.
No, for those who know, Precambrian is supposedly the oldest rock, billions of years old. Tertiary is recent, younger than, what is it, 50,000 years? I don't even know what it is. It's the most recent, from a geological deep time scenario, it's the most recent time, and it's on the bottom of the Precambrian rock, which is supposedly the oldest. And these are like pretty good sized areas, Doug.
Yeah, one of the places we visited, he took us out to a place called the Chinese Wall, and that's kind of a neat spot because and you see all these dikes, and they stick up above the rest of the rock. They're harder than the rock that's around them, and so the rock erodes away from around these intrusions, and so they're sticking up all over the place.
Yeah.
And so that's kind of a neat thing that we saw. But that is the volcanic rock that's actually capping this mountain, that's Precambrian, and so
now, Doug, How do they? Yeah, because volcanic rock is really the only kinds of rocks that you can date, at least radiometrically, I suppose. You know, sedimentary rock. We've gone over this many times, but there might be somebody coming in. Sedimentary rock, the ones that the fossils are all found, you can't date those. So this volcanic rock is supposedly Precambrian, which means it has very few, if any, fossils in it at all, right?
Yeah. David Overperler was showing me this geology book, and he's not a geologist, so he really didn't realize the significance of that. But I picked up on it. I looked at the map of it, and there it was. You know, the top is the Precambrian, and underneath it is. And what I found amazing is that they really glossed over that as it was just sort of a normal thing, you know. And
well, they call them unconformities or nonconformities or whatever.
Overthrusts.
Or yeah.
You know, it's sort of.
The thing about it is, overthrusts. Again, we go for truth in lending here. There are such things as overthrusts, but they're generally fairly small, and they're very easily seen. You could see breccia and certain movement. You can see it here. These kinds of formations, Doug, with these miles of area, there's very little, if any, oftentimes no movement at all. And sometimes what's so strange about some of these unconformities, it's not only even straight. This one was fairly straight, as I remember, Doug. But sometimes you have them where they're like waved, and all kinds of strange things.
Well, that's what we saw. That's what we saw at the Empire Mountains.
And the Empire, that's what I was getting to. Yeah.
The top part of the Empire Mountains is Permian, which is supposedly the age of the fishes, but the bottom part is Cretaceous, which is the age of the dinosaurs.
Yeah, it's the last age of the dinosaurs during the Mesozoic.
Right.
Yeah.
And so you have this inverted spot, but where we saw the Clifford Burdick was the first person to point this out,
right.
And he was a geologist at the University of Arizona and also at the El Paso, University of Texas El Paso.
He's kind of like one of the first Cretaceous geologists that I remember reading about. Was he doing stuff in the 40s, Doug? Or?
Yeah, he was in the 40s and
50s through the 60s, I think. Yeah, it was his big 60s
time. And he was he contributed to the Creation Research Society, some of the earliest works then.
Right.
That's where I picked up. There was a video that is actually a slide presentation that I had that talked about his work in this particular area, and to actually go there and see where the contact line was. You go in there's a road cut where the old road and the new road meets, and you can see that and it's really looked like a mud flow over on the top.
Yeah.
Looked like it's all unconsolidated mud. It didn't look much like rock at all.
I know it.
And the bottom was, the Cretaceous.
Cretaceous,
rock.
Yeah.
And then if you go down the road, the old road a little bit, you can see there's a spot where you can see the contact line, but it's really quite undefined. There's not much to it, but to have that little low angle fault move all this way across the entire
go uphill.
mountains had to go uphill and to actually overcome this wavy thing.
It does stretch credibility. Now, the Cretaceous is that's the strata you'd find the T-Rex and the Triceratops and things like that. Generally, so that's how you get it. But the Permian is the fishes and stuff like that. But you got Triassic, Jurassic before you get Cretaceous, according to the deep time thing. You also have you got the Permian. Permian goes into, I think, right after that. No, Permian. I think I'm trying to remember how it goes. It's been so long, Permian. Yeah, then it goes into Triassic, I believe. Yeah, because Devonian is before that.
Triassic, Jurassic, and then.
Permian actually is reptiles start supposedly emerging. We don't buy into any of this stuff. We believe these were laid down during the flood or post-flood action, and it's very obvious this was happening fairly quickly.
And you can see this is obviously flood deposit. And it's something that was laid down by moving water. It wasn't laid down by the rocks being created first and then shifted up, shoved over,
and put on with no evidence of anything like that. Yeah, I know.
And so I think that is really indication that the flood model makes a whole lot of sense. And I don't think that we actually saw the good stuff that Burdick had in his video.
Yeah, we were trying to find it, and we found some stuff that looked like, but he really had some very amazing things. I think we'd have to spend several days there, Doug, to be able to find that. We did get some close things that you could see it, but not like quite the way he had it. But still pretty good though.
But anyway, Jim Clarke really had a lot of
things to say,
and so we're just going to let him
run with it
and go with that.
Would it be taking the original creation rock, the granites, then, and it's separating them out in a sense because of heat? That's what's going on here, then, huh?
Yep. And it cooled real rapidly when the water came out.
Okay.
And you notice how this was brittle? How you dropped it and it cracked in two?
Yep.
And you've got, see, you don't have like solid rock. You've got all these other elements in there, like inclusions or whatever. That's why it broke so easily.
Yeah, let's just, before we pass, one more thing. Because you believe, as I do, that the granites are really the creation rocks, the bed rocks.
Yeah.
And why do you think that would be the case?
Well, the first thing is that, number one, this rock will never form naturally.
It can't even be formed unnaturally.
I don't think you can form it unnaturally.
We can't even form it in the labs, right?
Right. Okay. You can't even form it in the lab. And my opinion is that, you know, God created this planet for life. Okay? The rocks that we find have everything in them that we need for life. Okay? You've got the Earth's crust is made up predominantly of two rocks: granite on the continental crust and basalt in the oceanic crust.
That's what I was saying. Yeah. Okay.
Okay. So the granite sits on top of the oceanic crust. Okay, because the oceanic crust is denser, heavier, and the granite will sit on top of it.
And that ocean, that's the basalt, right?
Yep.
So would you consider basalt, is that a creationary rock?
I also believe that is a creation weak rock.
Okay, all right, that's what I was getting at. Because it sounded like there were some basaltic things happening during the time of the flood as well.
Oh yeah.
They were getting erupted out through. Okay, that makes sense. Okay.
Okay.
Cool.
So that's my opinion on the whole thing. So what was happening at the end of the flood, you had all this channelized flow. Well, to the east of us, there's a very large canyon known as Salt River Canyon.
Okay.
It's considered to be, it's called the Little Grand Canyon. It looks just like the Grand Canyon.
Ooh.
And I think that this material here, the Camel's Head Formation, is the material that was eroded out as Salt River Canyon was being carved.
That's the stuff that was carved. Ah,
That makes sense.
that does make sense.
This formation is more than 2,000 feet thick. It's been measured to be more than 2,000 feet thick. And as I said, it continues out west of us here, goes out west along the Salt River. It fills Salt River Valley just in this area here, starting at Camelback Mountain, going to South Mountain, and then continues on out that way. You find it over at Fountain Hills. There's a large mountain over there called Red Mountain. Same exact material. And if you stand on top of South Mountain, you look over it, you can just look at the Camel's Head Formation going right on across the valley.
Really? Wow.
You guys were just up there.
So
it's almost like I'm getting this scenario I think about in the beginning where, you know, you got this ball of water here called Earth, and in the middle he says, let the dry land appear, and that's that's the granites coming out.
Mm-hmm.
Is that formed from the basalt, or is it totally out of ex nihilo? I mean, how?
I think it's ex nihilo.
That's what I'm wondering, because it comes out of nothing. You know, it's not basalt. It's not. They're different chemical compositions. I mean, of course, the granite's a kind of conglomerate. It's got
a conglomerate.
Yeah,
it's
got
a
all
mix of
kinds
everything.
of things. Basalt is what it is. It's the
basalt is what it is.
But the granite lies on top of the basalt. Very interesting. That is very fascinating.
But you just look at this formation, and it just screams that this was deposited very, very quickly. Then as everything was still moving up, because you had all of this plate tectonics going on, all these plates colliding into each other, the soft granite that's been heated up by all of this radioactive decay is just easily deformed and pushed up, and it's just being pushed up. And this rock, which was originally deposited horizontally, is now tilted up.
Yeah, something. Yeah. Wow. Well, thanks so much for that. That was very good. I really appreciate that.
Anybody needs it?
So we're standing on the limestone right here, right now?
Yeah, this is the Kaibab limestone.
Okay.
And it has little different variations in the texture and stuff. But basically, modern day limestones are formed by the disaggregation of mostly shells, marine organisms, brachiopods, and all kinds of marine organisms that have calcium carbonate shells.
Do you see any fossils? And I didn't see any, but I was really looking
Yeah,
at
we're going to
it.
see some up at the other point.
The other point, okay.
Fossiliferous layer that's quite. We're going to take a look at it.
We have with us Sal Guardina. He's going to tell us, this geologist. You're right from here in Arizona, right?
That is correct.
Where do you live in?
Mesa, Arizona.
Mesa, Arizona. Yeah. It's a little nippier up here than it is where you're used to, isn't it?
Oh, absolutely.
So you can tell with the hats we have on us here, but it's
I'm
quite,
as cold as you are.
it's
man.
quite cold, but it's exhilarating. It's amazing.
Yeah.
So we're going to go see some. Which point are you talking about? Where the fossil list?
That's up there by the lodge.
By the lodge. Okay.
Bright Angel Lodge, near the Bright Angel Chill.
Okay. Good.
But the modern day limestones consist mostly of disaggregated silk-sized particles of basically ground up marine creatures.
Right.
But that made of calcium carbonate, but calcium carbonate comes in two forms. It's what's called aragonite and calcite. Compositionally, they're the same thing, CO2, but the aragonite from the shells has a different structure to it. The crystal structure is a little different geometric shape than the crystal structure of calcite. So that's how we could tell if that those disaggregated silk particles under microscopes and using different equipment, X-ray diffraction equipment, could tell that those are mostly shells of marine animals. Now the limestones throughout most of here, of the Grand Canyon, are calcium carbonate primarily.
So were they formed later at the same time, or what do you think?
They were formed, we believe rapidly, right during the worldwide flood, but they don't consist of all these little silt-sized particles of ground-up shells. They actually are pure, almost pure calcium carbonate, mixed with various amounts and they're clay-sized. They're smaller than modern-day marine deposits. So you're talking about clay-sized particles, and which are very, very small. And there's also mixed up in them some sand, various amounts of sand grains. Now, sand cannot be deposited in calm waters over long periods of time. In order for the sand to be mixed with the clay-sized particles of calcite, there has to be moving waters to carry that sand along and mix it with them and deposit it. That and other features show that these deposits were deposited by water.
Would you think this would be
Running
during the flood or post-flood or during?
During the flood.
Because it seems to me that the strata seems to get laid down and then the cutting happens later on. Is that what happens?
Yeah.
Yeah. Okay.
Yeah, the erosion, that was due to the retreat of the floodwaters.
Yeah. Okay. Yeah.
And that's what happened. Now, in these limestones are various kinds of fossils, mostly corals, there are sponges. And by the way, sponges, you'll see all these, I think, at the other point.
Okay.
We're going to look at a fossiliferous layer, but sponges are soft-bodied for the most part.
Yeah, that's how they preserve those.
And those are preserved, and there's a lot of sponges in the Kaibab in places. There are fragments of corals, brachiopods, and crinoids.
Crinoids, I would say they were
crinoids. They're usually all the stems, the crinoid stems, which are like sea lilies, and they're all disaggregated for the most part, including the shells, and it's like a hash of broken shells. You don't usually find complete fossils because they've been fractured.
Scumbled up so bad, huh?
Yeah. Once in a while you'll find a complete fossil, but it's like a hash of broken up marine shells and such. Again, indicating that there's no in situ seafloor found in any of the limestones going down the whole column here. in the Grand Canyon, all the limestones, you're not going to find what we call in situ seafloor, like a massive coral reef.
They were swept in here, is what you're saying.
They're broken up. They're all broken up and deposited in flowing water. You will find some algal mats and some fragments of corals and things like that, but you're not going to find an entire reef, you know, in the limestones that would indicate a calm water deposition at the bottom of the seafloor.
That's fascinating.
Okay.
The mystery with secular geologists is, why did the erosion stop on top of the Kaibab? And they think that there's some sort of a Cretaceous erosional event, but it still doesn't explain. And in most places, the Cretaceous in a lot of parts of the world is sort of like near the end of the flood, latter flood, the end of the flood. But if you're looking at it in terms of runoff, the water running off, you know, it would easily erode, and then at some point, the down cutting began to focus into canyons.
The down cutting is the latter stage, because in other words, it's envisioned as the sheet flow went out, it basically planed. Right. Thousands of feet of sediment, but eventually it's going to get down to a point where there's some irregularities and it starts to channel.
Okay.
You know what I mean? And you
got fast-moving water, though. Right?
Oh yeah, fast-moving water, but eventually it will get to a point where it starts to favor this area and that area, and this was like an area where that got channelized out. So the latter phase of the flow is a channelized flow. The first phase is sheet flow. And then eventually you're going to get to irregularities where you start getting channelized flow producing deep cutting canyons.
So you're in favor of that, like more than let's say the breach dam theory?
Well, I think it could explain it possibly more, because the reason with the breach dam is that there isn't a tremendous amount of evidence to show where this gigantic Hopi lake was. Where the lake was.
Yeah.
It's hard to find any shoreline deposits and the actual lake deposits, and that some people have proposed some, but this lake should cover what, 10,000 square miles or something. You should find some more deposits of it.
I told them about. I've been in that area on the other side of the Palisades. We should go over to Desert View during the day. And we can get into depth.
We're sort of planning to do that on our way to Cameron tomorrow.
In depth.
The other problem.
I can meet you in the morning. I wanted to point out something about the red wall limestone. Are you filming?
Yeah.
Yes.
To bring to remembrance the research that Steve Austin did when he found those nautiloid fossils in the red wall, and I mean they're in that layer. They're everywhere, and they go all the way out to Las Vegas. And he estimated how many millions?
They're billions.
And some of them are in positions that are vertical, kind of like the polystrate. Well, they are polystrate, but like the trees that are polystrate, showing that he was able to prove and get published in the secular literature about these nautiloids, representing, at least in that particular layer, that the water was moving very fast. And
what had to do that?
For a limestone, it completely blew away the theory of the limestone being deposited in coral reefs or whatever.
Yeah, they measured the orientation.
There's no coral reefs. You can't find it. They're not found in the canyon. It's just a solid layer of limestone.
They've measured the orientation of these nautiloids, which are these mollusks, linear, extended cone type mollusks. And the orientation is, I forgot, it's like to the northwest or something, but the great majority of them are oriented, and they could only happen from a flow of water.
Was that the initial state of the rising of the floodwaters when they were coming in, or was that the back runoff?
Well, that was probably, down there is probably during the deposition.
Some sort of a flood current.
Because those are a lot of those complete, or they scumble up like the rest of the stuff you're talking about?
No, a lot of them are intact.
They are
and have been laid down in a particular orientation, and they've estimated from the number they could count in an area, and they go for 200 miles. I think they go even all the way to to Las Vegas or something. The area that they found, they estimated there's several billion of them.
Man.
Well, Rich, I think that our time with Jim Clarke was really interesting in that he showed us a lot of things about the Phoenix area that we really had no idea that this is. What I really saw was all the volcanism that took place during that time. to be able to imagine a time where you had this erupting in such a manner that you have 3 different calderas in the Superstition Mountain area, and actually the Superstition Mountain is itself a volcanic plug, just like at Mount St. Helens, only it's huge. And
it's ginormous, as the saying goes, yeah.
And so you can see why you can find gold in the area, because that would have been upwelled from the volcanic magma, and then all the area around the Apache Trail going out to Canyon Lake, you know, there's just indications of all kinds of violent upheaval that, in this area.
I don't remember, they haven't really found any diamonds or anything like that in this area, have they?
Oh no, the only places in North America that are diamonds are the place in Arkansas.
Parts in Arkansas, we've been there, yeah, but I didn't know, because sometimes volcanism can bring up that. I didn't think it talked about any of that, and I don't remember anybody mentioning that. But gold and silver, that kind of stuff comes up with volcanism, that kind of stuff.
And copper and
yeah.
And if you
that's all around the whole area.
Yeah, just west of east of the Boyce Thompson area was that deep copper mine.
Oh yeah,
where it gets down to 100. When you go down into the bottom of it, they have to use robots because it gets up to 130 degrees.
It's too hot, yeah.
Of course, that's not much different than the temperatures outside sometimes.
I know. So what's the big deal, you know?
Yeah.
Yeah, except there's no airflow, I guess, yeah.
Well, I think that Jim really showed us some interesting things. We thanked him for taking us on the Canyon Lake boat tour also.
Oh, wasn't that something?
And we saw a lot of eagles and things of that sort on that tour, and petrified wood. Logs.
Well, it looked like they were sticking right out. They looked like, it'd be fun to go in there and actually check that out, Doug, to see if that is a petrified wood. But that's exactly what they do look like, the ends of logs,
Well, we'll see you next time on Revolution Against Evolution.